Hey everyone. Thanks for joining NET302, Network Operations Management and Governance. My name is Sohaib Tahir. I'm a Senior Solutions Architect in our AWS Public Sector team and my co-presenter.
Hi, my name is Shiva Vaidyanathan, a Senior Cloud Architect with AWS Professional Services Organization.
So this is a Chalk Talk. We are going to do two Q&A. So we'll stop in the middle for questions, and then we'll also open up the floor for questions towards the end, so stay on. So how many people here are doing network monitoring? Awesome. How many people are experiencing challenges and pain points with troubleshooting networks? Awesome. How many people are using CI/CD pipelines, automation for network deployments? Cool. So we are going to cover all three topics. So we are going to cover network monitoring, look into some options there. We are going to cover network troubleshooting, how you can go about that with some of the AWS native services and features. And we are also going to end up with some network management around CI/CD and DevOps practices. So first thing first, what is network monitoring? How we can define it and how we think about that. So we think about network monitoring in 4 phases. The first one is the collect phase, where we basically talk about collecting metrics, collecting the data, logs, so that we can basically monitor them through dashboards, through alarms. And then based off this data, we can act upon and we can take certain actions. And we're going to dive deep into each of these sections in more detail. And then finally, we can use some features and services to analyze that data so that you can do troubleshooting, maybe do some proactive monitoring and things like that. So here's an example setup. So I have a public-facing application here fronted by an application load balancer. So the traffic is going through AWS Network Firewall for inspection and advanced security features.
You need to press the...
Sorry. So here's an example setup. So I have a public-facing application behind an application load balancer. The traffic is going through AWS Network Firewall. And then AWS Network Firewall, you can actually apply stateful, stateless engine rules so that you can filter traffic, you can monitor traffic, you can detect certain kind of packets and things like that. And then how you can go about monitoring something like this. So we are going to focus a lot on the AWS Network Firewall for this particular example, not so much on the application side of things, just as an example so that you can think about and relate to how we go back and tie back to those 4 phases that I talked about. So the first one is how to go about collecting the metrics and data about for the AWS Network Firewall. So the first one is metrics. By default, AWS Network Firewall provide you out-of-the-box metrics under AWS Network Firewall namespace. So within the CloudWatch service, every service has a namespace, and under that you can get some out-of-the-box metrics. So you can start from there. So for AWS Network Firewall, in this particular example, we have receive packets, we have drop packets, pass packets. So this gives you a quick insight into how your rules are working. So within AWS Network Firewall, you can have stateless, stateful rules. So this gives you a quick insight into how many packets were dropped by your stateful engine or stateless engine, how many of those made through your rules, so that you can quickly figure out if your rules are working the way they should. And then you can also push some custom metrics if you want to through CloudWatch agent and things like that from the application side to kind of correlate your out-of-the-box metrics and also your custom metrics. So the next part is logs. So in context of AWS Network Firewall, we provide you some out-of-the-box logs. For AWS Network Firewall and specifically, we provide you flow logs. We call them network flow logs. So this is kind of a snippet from AWS Network Firewall logs. It's called NetFlow. So this is just one log event. So logs are typically collection of multiple log events. So in this particular example, you can see that we are showing you where this packet came from, the source IP address, the destination IP address, source address, source port, destination port. And in the destination IP, you can see the private IP of load balancer. That's how the traffic normally travels or traverses through the VPC. Everything south of Internet Gateway is a private IP address. Even application load balancer is a public facing. So Internet Gateway is kind of a netting device which converts the public to private. So that's why you're seeing a private IP address as a destination in this case, because our traffic is going from network firewall to load balancer node, and then the load balancer is distributing that across application. And then we also provide you some metadata as part of this. We give you timestamp, we give you availability zone that you can basically use to correlate, what happened at what time, and then perform some troubleshooting and gain some insights. So that's the collect phase. Moving on to monitor phase, how you can monitor your data or your metrics. So the first thing is you can actually create CloudWatch dashboards. So here's an example of that. So CloudWatch dashboard can be basically a combination of metrics, alarms, and logs. So you can actually combine all these things in one dashboard. A good example use case for that is, for example, you are a network operations team. You are running your own network services account, and you build this CloudWatch dashboard with all the critical metrics that you are going to use to determine the health of your network. And now you have an application team which is separate, but you want to share this dashboard with your application team. And why you want to do that? Let's say application team is saying higher latencies, so they want to make sure that those higher latencies are not coming from network, or maybe coming from network. So the first step they can do as part of that is you can share this dashboard with the application team. They can quickly look into the dashboard and figure out if there's any network event going on, if there's any metric that they can quickly look into and figure out if this is a network related issue. Or if they don't, then they can focus their effort on the application side of things and figure out if the application is, if the latency is actually coming from the application itself. So you can do things like that with CloudWatch dashboard, and you can combine metrics, alarms, and logs. And then you can actually also filter the logs. So you don't have to throw the default or the raw logs. You can actually create filters on that log and pull that into your dashboard and share that with your other teams. So the second thing as part of the monitor is alarm. So there are two ways you can go about creating alarms within CloudWatch. You might be familiar with this. The first one is the way it has been for a while. You can pick a metric, then you can basically assign a threshold. You define the condition, how many times that metric breaches the threshold, and then you go into alarm state. It's more reactive, more static. So you can still use that, but the other feature you can use is CloudWatch anomaly detection. So the way CloudWatch anomaly detection works, you basically define a threshold. We call it a width. So it basically defines the band of your normal expected behavior. So anything outside of your normal expected behavior is an outlier. And then you can define how you want to generate alarm state. You can either generate alarm state when your metric value is above the expected value or below the expected value, all those different combinations. And then this allows you to basically proactively monitor your alarm. So the first one was static, which is more reactive. This is more proactive. And you can actually, this way, whenever your trend is deviating from your normal behavior, your alarm will go into alarm state, and then you can trigger certain actions. And CloudWatch behind the scene is using statistical and machine learning algorithms to perform anomaly detection. So the other thing you can also do is you can combine multiple metrics. So if you have, like, let's say, metrics around counts, things like that, you can add them to other metrics, and then you can you add them, you can multiply them, you can perform different kind of mathematical operations on them, and then create alarms on top of those combined metrics. So that's also possible. So we talked about collect, we talked about monitor. Now let's talk about the act phase. So once you have the alarms, you can actually trigger certain actions based on those alarm states. So that's one way to do it. The other way to do that is basically use events. So the first way to use event is basically create like a cron job or a periodic event which can trigger certain actions. For example, you can have like a custom action that can look for certain data, metric data, alarm state, and then go and perform some custom action. Or you can actually do more of an event-driven architecture where you basically, whenever an event is generated, it is received by something like a Lambda function. You can go and you can perform certain action on your resources, such as changing the security group rule, or maybe changing the AWS network firewall rule to allow or block certain kind of traffic. And then you can also perform certain other kind of actions, such as you can auto scale. I think you guys must be familiar with this. Or you can use like systems manager to perform automation workflows, or you can even go down on operating system level and make changes to the network configuration on the OS level using systems manager custom action. Minimum, you can notify your operations team. So you can basically funnel your alarm, your event data into emails, and that email can belong to your operations team, and they can if there is a critical alarm for a critical metric, they can quickly look into that and troubleshoot the issue. So here's an example. So This is like a simple notification example. So you are sending your alarm state to a SNS topic. SNS topic might be belonging to your operations team. So whenever there's a critical issue, they will get notified. And you can also integrate notification into like Slack channels and things like that for like team-wide insights. So we talked about collect, we talked about monitor, we talked about how you can act on metrics and alarms. Let's now talk about analyze. So the first thing in analyze is CloudWatch insights, CloudWatch log insights. So we give you logs which you can store in CloudWatch logs, but those are raw data. So in order to kind of use that data to troubleshoot or to inspect what is going on in your network, you would have to filter that data out. So that's where the CloudWatch log insights come into picture. So this is basically, it allows you to write queries. So you can search, you can filter, you can maybe also perform some statistical functions on your logs and then look for maybe particular error type that is appearing in multiple log entries. So you can do that quickly through the CloudWatch log insights. And it allows you to return certain fields, so you can actually also filter out if you don't want to see all the fields as a result of a query. You can trim it down. You can only look for specific fields that you're interested in, for example, IP addresses in certain cases if you're troubleshooting for that, so that you can quickly look into what's going on in your network. The second feature within CloudWatch that can be really helpful is CloudWatch Contributor Insights. So Contributor Insights basically allow you to look at or quickly find the top contributors speaking to your application or basically interacting with your network and getting to your application. So in this example, you can see I have like top 4 speakers which are sending the most amount of requests to my application. So this can be really useful as well, because you can figure out, okay, if one IP address or one client is overwhelming your network, is that the normal behavior? Do you want to block it? You can monitor it. Maybe you can drill down further to inspect that and troubleshoot any problem if you are experiencing that in your network. And then you can see contributor insights by source IP, destination IP, protocol types, things like that. The third thing under analyze is CloudWatch metric filter. So this is basically, instead of, we talked about how you can run queries against your logs, but if you don't want to do that, you can also create metric filter. So metric filter allows you to look for specific things within your log, for example, 404 codes, 404 error codes, or maybe some specific terms. And when there is a certain threshold that is breached, you can actually trigger an alarm. So you're basically converting log into metric, and then on metric, you can create an alarm. So instead of you running queries reactively, this way you can proactively find certain things within your log and get notified or take some certain custom action. So that's where the CloudWatch metric filter comes into picture. And this is how they all kind of connect in context of, since going back to the example scenario, we are talking about AWS Network Firewall. So this is how basically you collect metrics from AWS Network Firewall, then you monitor them through alarms and dashboard. You take actions based on certain events or alarms using Lambda or some other custom actions, and then you can analyze certain data, like for example, AWS Network Firewall flow logs or alert logs through the CloudWatch functionality I discussed. So that was it for the network monitoring. So let's now jump into network troubleshooting. So in network troubleshooting, the first thing I want to talk about in this section is VPC flow logs. You might be aware of this. This is a best practice that you should be following if you're using a VPC. Enable this by default. So VPC flow logs allow you to capture a network flow data on ENI, subnet, or VPC level. If you enable it on VPC level, we will capture data for all of the network interfaces. And then you can push that data into either Amazon S3 or CloudWatch. And then all the CloudWatch features that I talked about, they will be in play. You can still use them with VPC flow logs. There are basically 2 ways you can configure VPC flow logs. There is a default format which you cannot really edit. This is basically when we launch VPC flow log, it always used to have this default format, which has like certain fields that we have predefined. But if you want to customize your fields, for example, if you're using like a third-party system where you are ingesting your logs, you can select certain fields and you can format your flow log format in a way that it is consumable by that third-party system. And maybe you also want to you're not interested in all the fields. You only want to look into like source destination IP addresses, port numbers, instance IDs, things like that, and you can define the order. And then now your flow log will be based on this custom format, which is also compatible with your third-party logging solution. So here So you can also analyze flow logs. Since the flow logs can reside in S3, you can also analyze it through Athena, which is basically SQL-like query experience. Then you can also ingest the flow logs into QuickSight for visualization to kind of gain quick insights into how your network health is looking through more of a visualization experience. Here are some blog posts which kind of go into a lot more detail on how you can use or analyze VPC flow logs with Athena and also analyze VPC flow logs with QuickSight. You can take a picture of this and scan the QR code, so it will give you the link for the blog post. And these slides will be available to you, so don't worry if you haven't captured or taken a snapshot. So the last thing I want to talk about in this section is traffic mirroring with Amazon VPC. So traffic mirroring basically allows you to, it's kind of a packet capture, but you can actually take it and you can send it to out-of-band third-party inspection device that can be running on EC2 instance. It can be running behind a network load balancer, or it can be running behind a gateway load balancer, which is our load balancer for inspection devices. So this is more of an out of band. So if you don't want to inspect the traffic inline, you can use this feature. So this allows you to basically capture traffic, and you can define the filter. You can only capture maybe specific kind of traffic from specific IP addresses, or maybe only TCP-based traffic or UDP-based traffic, and then you can ship it to an out-of-band target. And that's where you can basically inspect the traffic, apply some rules, so that you can monitor, you can gain insights. You can also do some threat detection, things like that. It basically takes up the original packet, encapsulates that into VXLAN based header, and then ships that to the target over the UDP. So the target device needs to support UDP, and you need to open the UDP ports on the security group. So with that, I will hand it over to Shiva to kind of talk about the rest of the stuff within the network troubleshooting.
Thank you. Thanks, Shoaib. So the next feature that we are going to talk about is Transit Gateway Route Analyzer. So in this slide, you see a common setup that we see with customers, where you have a bunch of spoke VPCs connected to a transit gateway in a region, peered to another region, which is connected to on-premise through a VPN connection. And you can imagine the diagnosing connectivity issues gets complex if you have a chain of connectivity using transit gateways. And that's where Transit Gateway Route Analyzer comes into help. It's a feature that allows you to debug routing issues on your global network. So the way it works is it provides hop-by-hop details for your source, between your source and destination, and provides what route table has that issue within your transit gateway. So in this example screenshot, you see a source IP and a destination IP, and then the list of hops, intermediate, and on the top, you see whether the status of the forward flow is connected or it's not. If it's not connected, it provides where exactly that particular issue resides so that you can act upon. So we spoke about Transit Gateway Route Analyzer, which is more of a level above the VPC scope. Now let's get into the VPC scope and what features we have within the VPC to sort of analyze the connectivity issue in a more granular fashion. So VPC Reachability Analyzer, again, this is an example, a common example that we see. You have a bunch of EC2s connected, having connectivity issue, and the connectivity issue can be for, like, it might depend on many kinds, right? You might have a security group that is not allowing, or ACLs that are preventing, or the routing itself. So VPC Reachability Analyzer allows you to give an hop-by-hop details and also look into the various controls that you might have for connectivity. So in this case, you are trying to inspect more than just pure layer 4 routing. So it can detect if there is a security group that is blocking, or ACLs. Recently, we also had a launch for it to support the transit gateway as well. So it can detect a transit, up to 2 transit gateways in the network path. On the right, you see how we can use these features in a more automated way. So let's say if someone is pushing a security group change or an ACL change, and you want to proactively detect whether this change would impact connectivity between your critical applications. So you sort of get this change in security group fed into your CloudTrail. So any API calls is fed into CloudTrail. You can then feed into EventBridge that can have your Lambda functions that runs your VPC Reachability Analyzer, gets the findings, and then once you are okay with the findings, you can then promote it via SNS. And this setup can be fed into your pipeline. With that, we will take a pause and look for any questions that you might have on network monitoring and network troubleshooting.
The thing is, all the monitoring system you are explaining is on the virtual level. For example, our company, we are going to multi-cloud system, and AWS is one of them. On our data center right now, sometimes it's happened we already facing some issue on a specific day and a specific time. The application has a high latency. And we are looking for where is the issue. One of the parts is network and switches. We are looking into it. On the virtual level, I understand we have access to all the logs and everything. How we can get access to the passes and the physical switches our data is passing from the company to the AWS?
So the question is how you get access or data on the physical path from on-prem to
the
AWS.
Logs of the switches to the physical to see the passes going on which part we may have an issue or not. Just to look into that logs and see. I know if we come to you guys and say, hey, we are facing this latency until into our application in AWS, you guys go and check the logs. But sometimes the customers, actually the managers, are pushing you as a technical person. Okay, where is the logs? What you can see in the logs, but we don't have that access to the physical layers.
So today, the way to go about that, I think you already kind of mentioned that is if you run into that kind of situation, you can open a support ticket, work with the support, and they can provide you the logs. But I think we are also working to make. I think this is more of a roadmap question, I will say. So I cannot, but I'll say I think we get that feedback. This is a good feedback. We are going to take this feedback back to the service team. But today, I think the way to work on this kind of situation is work with the support team, because they can look into the underlying physical stuff and tell you, hey, what's going on, if this is an AWS level problem or some other problem. We focus a lot on the higher level, like you said, which gives you visibility. But still, some of the tools that you have always used within network troubleshooting, like traceroute, MTR, stuff like that, you can still use that. And if you see any problem there, you see higher latencies, or you see that packet drops, you can send that data to us, and we can work and we can figure out where this issue is coming from. Well, I hope that answers the question.
And just to add, so there is also a tool called Network Status Board, which gives you a high-level overview. If there is an outage within a region or an AZ, it might give you a high-level overview, if not the hop-by-hop details.
So one here and then here.
Yeah, so thank you guys. So we have the route analyzer. So you have sort of a multi-region transit gateway peering connection, so you can analyze routing. And then you have the VPC Reachability Analyzer. Now, this is fairly new, and how this is play when you have sort of a centralized environment with many VPCs, transit gateway attachment, sort of third-party appliances in the mix, gateway load balancer, stuff like that. Thus, the reachability analyzer, which is in this case I think it's for VPC, will this help us to troubleshoot like a sort of a broken point or something?
Yes. So the question is, does VPC Reachability Analyzer help you to help debug connectivity issues in a centralized manner?
Yes, correct.
Yep. So the way that I would look or recommend is the transit gateway route analyzer that we spoke about. It's more of the routing feature. So you can use that feature to specifically debug any routing issues. But let's say you have routing in place and the issue of connectivity is not because of routing, but maybe because of security group or ACLs, then you might want to look into VPC Reachability Analyzer. And if your overall global network setup is not going beyond 2 transit gateways, then VPC Reachability Analyzer also allows you to look into the transit gateway route tables up to 2 levels.
So even though if I have like 2 spot VPC attached to transit gateway, and
Yes.
I want to analyze, I want to see security groups, network ACL, how it's impacting, where is the traffic being blocked or something, I can see through the transit gateway attachment as the VPCs communicate each other, right?
Yes.
Yeah.
So the VPC access analyzer also allows you to have, like, if you have inspection device in between, you can just also enable that switch, and thereby you can look into what's man in the middle device going.
Yeah, so I think in terms of the how to go about this, I will say if you're using transit gateway, start with the network analyzer, which is basically was built for transit gateway, and then use reachability analyzer as like a complementary tool, because network route analyzer is free of charge as well, so you don't have to pay for it. That's another important point.
Thank you.
We'll take one more question, and then we'll cover network management, and then we'll open the question and answer again towards the end. A gentleman over here.
For the network troubleshooting tools you were showing us, are there costs associated with all of those tools?
So the question is, are there costs associated with all the tools? So the transit gateway route analyzer is a feature that comes free of charge. The VPC flow logs, the ingestion to CloudWatch, whatever pricing for CloudWatch, that's the charge that is associated. And VPC Reachability Analyzer, you have cost for every analysis that you run. For the VPC traffic mirroring, we need to check. I think there is a cost associated.
Yeah, I think there is a cost for that, and then you will also have a cost for running the third-party EC2 instance or inspection device that will be receiving the traffic mirroring traffic.
So until now, we saw how to monitor your network. We saw how to troubleshoot your network. Now let's see how to manage your network. So the way that we look through to manage your network is through NET DevOps. So essentially, we want to incorporate the principles of network development and network operations. And in the screen, you see that you need to have infrastructure as code for your networking. So you need to build your source code, build the source code for a specific configuration that you want to achieve. You then test against that specific configuration. You then plan for releasing that configuration in the environment. So this incorporates the best principles of network DevOps or network development. And then you follow the practices of network operations, which is deploy, operate, monitor, and release subsequent configurations. So some of the components that will help is, as I mentioned, you need to have infrastructure as code. So you can use CloudFormation, Terraform, CDK, that depends on your choice. Have it source controlled. So you need to have either AWS code commit if you're going native, or GitHub, GitLab, depending on whatever source control you're using. And you need to have it integrate with some form of CI/CD pipelines. Some of the services, native AWS services that helps in this journey is AWS code commit for your source control, code pipeline that integrates and deploys, code build for build phase, and then CloudFormation to deploy across accounts, across regions, and then SNS for promoting, having a control on what you promote to the environment. So let's walk through these phases and apply the principles of NET DevOps in practice. So in this example, I have a prod VPC staging or a dev VPC connected to an on-premise through an AWS VPN connection. Now, let's say the requirement is to move this setup into a transit gateway and a DX model. And let's walk through the principles of Net DevOps here. So this is a journey that we will walk through. So we have source code. We'll see how to build and unit test, deploy them, test and validate, how to go about manual approvals, and then how to deploy it in prod. So the first step is the application team requests you for that change, right? They want to move over to a transit gateway DX model. So you build for that specific configuration, what are the things in form of infrastructure as code. So in this case, you want to build a transit gateway, you want to create the route tables within the transit gateway for that change. You want to have a custom resource to trigger the Lambda functions that can run the VPC analyzer or the transit gateway route analyzers that we spoke about. Then you want to do some sort of unit testing. So typically, we recommend to use the CFN lint for syntactical checks for your infrastructure as code, so that can catch JSON errors or YAML errors before you deploy it into the environment. Then you can use CFN NAG. So the CFN NAG is a utility that allows you to create rules for over permissive security groups or ACLs that you might be managing using pipelines. So this might be extremely important for the security team because you don't want your rules to be overtly permissive. So once you run build unit test, then you want to deploy it to dev. So you use CloudFormation to deploy to the dev environment. You then validate using the analyzer test features that we spoke about. You then use SNS to, once you are okay with your findings, you then approve those changes, and then you promote those changes to production. So this is the steps that we spoke. Now let's see how this feeds into the actual code snippets. The example of we are using Git as a mechanism. I think everyone is familiar. So you sort of clone the repository for your that has the code for your infrastructure. You then add the changes. You develop the code. You add those changes. You then commit those changes to the repository. Here is an example. So in this screenshot, what we are trying to show is you have a pipeline which takes source as the AWS code commit. You have the repository as the infrastructure repository, and then you use code commit as your source control. So once you have the source controlled, any push to your master branch triggers the pipeline, and the next phase in the pipeline is the build. So here we are using image called lint nag, which we'll see later how that is built. But essentially, we are using code build as a service to build whatever unit test that you might want to have. The outcome of this, once you perform the tests that are required, is a deployable artifact and with a set of build variables that you want to transition for your CloudFormation. So the next phase is once you have completed the unit testing, you want to deploy them into an environment, into a specific account, maybe in multiple regions. So here we are using CloudFormation as the deployment mechanism and StackSet as the means. StackSet allows you to deploy it across multiple regions and multiple accounts. So we are passing the account IDs where we want to deploy these changes, and then the regions to deploy as well. So once the deployment is done in the dev environment, you want to promote, before promoting it to production, you want to manually approve so that you have guardrails of what gets deployed into the production environment. So we use SNS as an example here, where you are sending a notification of the findings that you might have got from the analyzers that you have in the environment. And this is an example of a Docker container image that we are building that does CFN, lint, and nags. So you can incorporate any custom features that you might want to have, like Ansible, run some playbooks, get those outcomes of the playbook and before you get into the deploy phase. How this ties in together. So on the left, you have AWS code commit, which triggers the pipeline. You build using CFN, lint, and lang to perform the syntactical checks. Once the tests are successful, you then deploy them to the staging environment, run the analyzer tests, outcome. Once you are satisfied with the outcome of the analyzer test, you then promote the changes to production. You then shut down your VPNs, and then you have a architecture with transit gateway and direct connected. Here are some of the blogs that helps, especially I didn't touch upon how to do the automation and include that in the pipeline for VPC Reachability Analyzer. So you can just add as an additional step in the pipeline snippet that I had showed. The SDNO orchestrator, or the serverless transit network orchestrator, helps you to build transit gateways at a global scale. So this is another blog post that we have that helps you to kickstart. So the key takeaways of this talk. When you're doing network monitoring, collect the data, monitor the data, create the alarms that are required, be proactive while you are defining the alarms, act upon suitably, and then analyze the data using the insights features that we have. VPC flow logs, traffic mirroring, route analyzer, VPC reachability analyzers. These are the common features that help you to debug and do network troubleshooting. And then deploy the code using infrastructure as code, use pipelines, build, test, validate before you deploy them in any environment. And we do it using network DevOps for network management. We open the forum for questions.
With the network firewalls, what are the capabilities for like HA and load balancing with those?
Can you repeat the question?
Like for high availability with network load balancers, do you have the ability to with the network firewalls to use multiple ones and bridge them, or how exactly is that capable? Same for load balancing. Can you load balance between multiple regions with same ones, or how would directing traffic in that sort of case work?
Okay, the question is, how does load balancing work with AWS network firewall? So AWS network firewall is a managed service. So you define the subnets in which the endpoints need to be present. And this just is an ENI behind the scenes. And you define which subnets or which AZs those ENIs are present. So the recommendation is you have at least in 2 AZs, and then we manage the scaling of those nodes that are provisioned for AWS network firewall.
Yeah, behind the scene, we perform the load balancer, so you don't have to worry about that. What you have to do is what Shiva said, just select the ENIs and deploy those ENIs in specific subnets. And then behind the scene, we'll load balance that. Any other questions? I'm also, so you can also copy our email addresses from the slide. So if you want to send questions later, feel free to do that. And please take the session survey in your app and let us know how we did on this one and how we can improve this in the future summits. Any other questions? So there was a question over here.
In one of your slides, you had the network firewall and then the application load balancer behind it. Mm-hmm. So when you write rules on the network load balancer, can you specify FQDN of the load balancer, or how does it work? Because application load balancer doesn't have static IPs, right?
Yeah, so AWS Network Firewall is an inline inspection device. So you don't really tell the AWS network firewall to send the traffic downstream. So what you're doing is you're injecting the network firewall through the routing in the path of the load balancer. So if you don't have a network firewall, what will happen? The internet gateway is going to send the traffic directly to the load balancer. But when you want to include AWS network firewall, what you will do is you will create a route table on the internet gateway, point that to the ENI of the network firewall. So the traffic will basically, internet gateway will first send that to AWS network firewall, and then whatever rules you have created on the network firewall, that they will trigger, perform whatever inspection detection you want to do, and then the network firewall will just simply use the routing within the VPC to send the traffic down to the load balancer. Because remember, so anything south of internet gateway is a private IP address space. So internet gateway, when it sends the traffic to the load balancer, the destination IP at that point is the private IP address of the load balancer node. So once the inspection is done, network firewall simply forwards that traffic through the routing to that private IP address, which is basically enabled by the local route within the VPC. Does that make sense? So no FQDN is needed in short, in terms of, I provide a long explanation because that's how it works, but that's the internal workings, how it works. Hopefully that answers the question. So there was a question here.
Waiting till the end because it's a little bit super specific, but I'm working on something for a client and they want to do PR specific builds of an application that runs in containers in ECS and have them run when there's traffic and then set desired state back to 0 so that the containers effectively turn off when someone's not viewing the PR. And we've got it pretty much working, except it's behind an ALB, it's got target groups. When they're off and we need to turn them back on, we need to detect that somewhere in the network stack. And we've been debating, target groups don't work because it doesn't get that far before 503 error occurs. ALB doesn't give you the host header, so you can't detect which target it was trying to go to turn that one back on. Right now we're looking at the WAF and watching logs out of the WAF because that has all the pieces we need, but way more data coming through that log than we really need. And I'm looking at some of these pieces and thinking maybe there's another place I could look. So I just thought I would throw that out there and see where is a good place for us to find this data. If somebody hasn't accessed the server in 60 minutes, we want to turn it off. And if somebody accesses it again or tries to access it, spin it back up.
So the question is, where do you look at the data for specific 503s that is available in the container stack ecosystem? And you have already looked into ALB and WAF in doing so. I think one of the ways would be to look into the log insights and then create specific metric filters that might come for the container ecosystem. That's one space that we can. And
you're looking for specifically for 503s, right?
Well, when the container's off, what happens is you get a 503 at the ALB.
I see.
So I can detect that also at the WAF because it's giving that answer back.
I see.
But
Okay.
everything behind that is blind. If I want to turn it back on, they're all stopped. So I can't look at those logs. They're not really useful. It would be something above that.
I see. So I think, what Shiva is saying, one thing you can try it out, and you would have to test it. You can ingest those logs into CloudWatch logs and then create a metric filter. And you can do it for WAF or ALB logs, regardless. Create a metric filter to look for those 503 errors and then trigger an alarm. So, and then alarm, you can basically, you can cascade the alarm into SNS and you can trigger a custom action on that. So that might be one way to do that. But you said you have to do it in 60 minutes, right?
I mean, we'd adjust. We have a pipeline. And
so maybe start from there. Create a metric filter. That will be more like proactive. You don't need a human intervention in doing that. But if you want to have like more query kind of experience, then you can use the CloudWatch log insights and run and you can save the queries, by the way. You test out all different combination of queries. The one that works, you save it and then you run that. So let's say the metric filter detects that there is like 503 happening. So you get notified, then you already have a saved query. You can go back to it and run that and figure out the specific entries, get the filter data. Does that answer your question?
I think so. The log you're telling me to look at, though, would be the WAF log.
WAF log and ALB logs as well.
Okay.
Yeah.
So you can.
We're using WAF. It sounds like we're heading down the right path.
Yeah.
And actually, one of the features that he briefly touched upon was the metric map. So you can combine two metrics, like look at from WAF level and use ALB, and then have a combination to trigger the alarm upon.
Cool, thanks.
Yep.
My question is a bit simple. When will the slides and I'm assuming YouTube videos be available to review all this?
So the question is, when would be the slide deck and the videos be available? Is it by, I think, one of the
Does someone know from the
production team?
When the video would be available and when would be the slides available? The slide for the session. Actually, all the sessions. So yeah, we can provide you more specific dates, but typically we make it available within a week. And there is like an event website, so that's where we historically have put all the slides and decks and also the video. YouTube video will be like a little bit later, I guess, but the slides should be available on that events page. So I think it should be in your app, but if you can provide us your email, we can provide you like more specific information on that. Yeah, sorry that we don't know the exact dates. Yeah. Any other questions? All right.
All right. Thank you.
Thanks, everyone.